As a self-taught developer, the best way to land a job in 2025 is not by chasing recruiters or applying to endless job posts, but it's by building your own software as a service product. Why? Because building a software as a service gives you something no bootcamp certificate, tutorial projects, or course can offer. Proof that you can take an idea, design it, build it, deploy it, and even sell it by attracting real users. In today's world, companies aren't hiring based on degrees or polished resumes. They are hiring builders who can shape, solve problems, and create value. Building a software as a service is the ultimate proof that demonstrates your technical expertise in front-end development, back-end development, authentication, databases, deployment pipelines, and beyond. Building a software as a service showcases your product mindset, your ability to identify user needs. And even if you don't get hired immediately, you will likely have built something that can turn into a real software as a service business with actual income. And that is exactly what we are doing today. In this video, we are solving a real-world problem that most developers face: mediocre portfolios. A portfolio is not a project, but it has to be clean, well-designed, dynamic, responsive, and easy to update. That's why I built 10-minute portfolio, a powerful customizable portfolio builder that helps you create a stunning professional online presence in just 10 minutes. And in this video, I'm going to walk you through how it works, and then we'll build it together step by step from scratch. Step 1. Create an account. To create your portfolio, go to 10minuteportfolio.app, click on Create Your Portfolio button, and you will be asked to sign up using Google or GitHub. The whole sign-up process takes literally 10 seconds. Step 2. Creating your first portfolio. Once signed in, you will be prompted to create your first portfolio. You will go through a multi-step from wizard, each step designed to help you set up a full-featured portfolio. Step 3. Template selection. Start by picking a template. We offer both free and premium designs. Just choose one that fits your style and move on. Step 4. Profile information. Now, fill out your profile. Name, professional title, location, email, phone number, website, bio, and social links. Some fields are optional, but most are important. Everything you enter is validated using Zold with advanced patterns to protect against XSS attacks and ensure data sanitization, both on the front end and back end. Step 5. Skills and certifications. Add your skills and certifications. This gives employers a quick snapshot of what you are great at. Step 6. Work experience. Enter your work experience, roles, companies, durations, and descriptions. You can add as many as you want. Step 7. Projects. Add title, description, text tag, GitHub link, demo link, all the juicy stuff. Step 8. Final review. You'll review your portfolio before publishing. Here you can check your portfolio name and slug. The slug for your portfolio is the unique identifier used in the URL to access it publicly. For this one, the URL would be 10minuteportfolio.app/Jane Frontend React Portfolio. Choose if it's publicly accessible, enable or disable the contact form. Decide if you want to allow comments. Once you are happy, just click Create Portfolio and you are ready to go. Step 9. Publish unlimited portfolios. After creation, you can still edit everything, change the name, customize the slug, update the content, and even preview the full set before publishing. From the preview page, you can review every section to ensure it looks perfect. The contact forms allows employers to reach out directly to your email inbox. But to receive emails, you need to publish your portfolio first. So just click on the Publish button. That's done. Now click Live and boom, your public portfolio is aligned. Try sending a message through the contact form. You'll see it land directly in your inbox. Now, here is something powerful. You can create unlimited portfolios. Let's say you are applying to React jobs and Vue.js jobs. Just duplicate a portfolio and tailor it to that specific role. Change your title, projects, and skills, or whatever you want. Preview it, publish it again. It's that simple. Step 10. Enjoy premium features. Now, if you want unlimited portfolios, access to premium templates, and advanced features, just become a premium member. Go to the pricing page, click Start Premium, and you will be redirected to a payment page. Once the payment is complete, your account is upgraded instantly, and you can enjoy all the premium benefits. Alright, we are officially in the development phase of the 10-minute portfolio.app. And in this video, I'm going to walk you through setting up the perfect dev environment to build efficiently and stay productive. Step 1. Open VS Code and install essential extensions. First things first, open up your favorite code editor. For me, that's Visual Studio Code. Before writing a single line of code, let's get our tools ready. Install Next.js for Dev extension. This extension allows you to scaffold both client and server components with ready-to-use snippets. It's a huge time saver when working with Next.js app router. Install Tailwind CSS IntelliSense. This gives you autocomplete, class suggestions, and hover preview for Tailwind utility classes, so you don't need to memorize every single utility by heart. Set up your keyboard shortcuts. Shortcuts speed up navigation, formatting, and refactoring. Step 2. Set up project structure. We are going to follow a monorepo architecture. In our monorepo, we separate concerns by having two main apps. The first app is the Backend API application. This app contains all backend related logic. Think of it as the brain of the application that handles data, security, and integrations. Here is what this app handles. API routes. Built using Next.js API routes under the app router. This is where your RESTful endpoint live. Authentication and authorization. We use Clerk for authentication. It handles sign in, sign up, and session management securely. Authorization logic, like who can access what, is also handled here. For example, making sure users can only modify their own portfolios. Security. This app includes CSRF Protection to ensure that only trusted domains can interact with the API. CSRF tokens to prevent cross-site request forgery. CSP to add another layer to prevent injection or attacks like XSS. And secure HTTP headers. Data validation. We use Zoe to strictly validate all incoming data from the client. This ensures no malformed or unexpected data is processed. All inputs are sanitized to prevent injection or manipulation. Errors are returned in a developer-friendly format. Database layer. We use MongoDB as our database. It's a fast, flexible, and scalable document-based storage solution that fits perfectly with modern JavaScript-based applications. For interacting with MongoDB, we use Mongoose, not Prisma. Why not Prisma? While Prisma is great for relational databases like PostgreSQL or MySQL, it introduces unnecessary complexity when working with document databases like MongoDB. On the other side, Mongoose is the best ORM technology for MongoDB in Node.js applications. It allows us to define straight schemas to ensure data consistency, to add powerful validation rules directly within our modules, handle pre and post hooks for tasks like sanitization, to apply advanced features like virtual feeds, indexes, and custom methods, and easily manage relationships between documents using references, which is very important for building real-world scalable apps. This makes Mongoose a robust and production-ready solution, perfectly tailored for MongoDB's document-oriented nature. We are also going to use other modules like repositories for module logic. Instead of calling Mongoose methods directly inside routes or controllers or modules, we use a repository pattern to encapsulate all our database operations. Using repositories improves your code base structure, maintainability, and scalability, especially in large apps like software as a service platforms. The second app is the Frontend application. This is the client-facing part of the app. It's what users see, interact with, and use to create their portfolios. Built with Next.js 15 app router, it includes UI frameworks, tailwind CSS for fast and responsive layouts, Shadcn UI for UI components, Framer Motion for smooth animations. Client-side security. Sensitive pages are protected with Clerk middleware. Inputs are sanitized and validated with Zoe on the client. API communication. We will be using Axios to securely communicate with the Backend API. This will include authorization headers, retry logic, and error handling. If you are interested in backend or frontend development using Next.js, this project offers some of the most valuable and practical content on YouTube right now. Without further ado, let's move on to the next step. Step 3. Initialize projects. Now let's initialize the project using Next.js and Burn. Create a folder named YouTube_10-minute portfolio. Inside this folder, create 2 directories. API folder for all backend logic, APIs, authentication, and database. Front folder for the Next.js frontend where users interact with your portfolio builder. and run bound x create next app at latest dot. The dot at the end means install in the current folder. Once it's done, do the same for the backend folder. Step 4. Link and configure servers. Now let's define our dev scripts. In your package.json, for both front and API, we want to edit the script to run in a specific local server. So edit the dev script. Cross-env is an additional package that needed to be installed. This line sets the environment to development and tells Next.js to run on port 3000. So now you have two local servers, localhost 3000 for the frontend application, localhost 3001 for the backend API. Files in both folders and define these URLs. Step 5. Git setup. Delete the .git folders in both front and API. Why? Because this is a mono repo. You want version control only at the root level. Then in YouTube underscore 10-minute portfolio, run git init. Create a simple README file to document the project. I use the VS Code Git extension to manage branches, commits, and pull requests without ever leaving the editor. Step 6. Run the servers from 2 terminals. cd to front folder and run bourne dev. cd also to API folder and run bourne dev. Now both servers are live. Step 7. Clean the project. In front/app/page.ts, delete all boilerplates. Also clean the public folder. We'll replace those with our custom assets later. Step 8. Deploy to Netlify. The first thing to do is to push your mono repo to GitHub. Then go to Netlify and create an account or login. From the dashboard, click on Add Project and select your GitHub repo. We'll start with deploying the API app first, then the frontend app. Once you've selected your GitHub project in Netlify, fill in the details for the project name. Name it something like YouTube 10-minute Portfolio API. For base directory, enter the folder name of your API app from the repository. In our case, just type API. For the build command, since we are using burn, type burn run build. For publish directory, for Next.js app, the output is in the .nest folder by default. About Netlify functions. Netlify functions are serverless functions that you can deploy alongside your frontend or API. They are useful for lightweight backend logic like webhooks, form handling, or dynamic API endpoints. By default, the functions directory is API/Netlify/functions. You can change this if you want. Now it's time to configure your environment for production. Click on Add Environment Variable and make sure to replace any development values with your production URLs, API keys, and other real credentials. After clicking Deploy, Netlify will start building your API app. But here is the thing, Netlify does not support Next.js perfectly out of the box. To fix that, go to Deploy Settings page, scroll down to the Build Settings section, click Configure. In the Runtime drop-down, select Next.js and click Save. Now return to Deploys page and click Redeploy to apply your runtime settings. Repeat the exact same steps for the front folder, your frontend app. The project name, it will be YouTube 10-minute portfolio. For the base directory, it will be front. And for build command, add burn run build. For publish directory, add .nest. Don't forget to update your environment variables and select the Next.js runtime. That's it. Once both the API and frontend apps are deployed successfully, you now have a full stack portfolio builder running live on Netlify. Amazing job. Let's move on to the next step. Setup backend structure. Here is the database design for our backend app. We have user module. This module represents each authenticated user in the system. Users are synced with Clerk and can have a role admin or user, a subscription plan, free or premium, and an account status active, banned, or suspended. We also have template module. The template module defines reusable layout designs that user can apply to their portfolios. Each template includes visual customization options such as colors, fonts, and thumbnails. Portfolios are the core content entities created by users. Each portfolio is built using a selected template and contains structured, personal, and professional information, including profile details, skill certifications, work experiences, and projects. Portfolios also include display settings and a unique slug for public access. The contact module stores messages submitted through a portfolio's contact form. It links back to the associated portfolio and helps track communication status with visitors, supporting actions like reading or archiving messages. First, in your project roles, create a modules folder. This will contain all our Mongoose schemas that map to collections in MongoDB. Inside this modules folder, create a file named user.ts. This file will define the schema and module for the user collection. Let's define our user schema. First up, we have Clerk ID. This is a required field. Every time a user signs up using Clerk or authentication provider, Clerk generates a unique ID for that user. We store this ID here to easily associate the user in our database with their Clerk account. Its substring must be unique and is required. Next is email. This field is optional, but when provided, we apply some useful formatting and validation. We stream it to remove extra spaces. We convert it to lowercase to maintain consistency. And we use a regular expression to validate that it's a proper email format. Then we have the name. This is an optional display name for the user. It's a string with a minimum length of 2 and a maximum of 50 characters. We also trim it to remove white space from the beginning and end. The role field helps us define what permissions our user has in our system. It can either be admin or user, and by default, every new user is just a user. This is helpful for access control. For example, only admins can create templates. The plain field tracks what kind of subscription the user has. It can be either free or premium. This allows us to implement premium features like custom domain, analytics, or more templates. The status tells us if our user's account is in good standing. It can be active, banned, or suspended. By default, it's active. This is useful if we need to temporarily or permanently restrict our user. We've also enabled timestamps, which means Mongoose will automatically add created art and updated art fields to each document. This helps us know when a user joined and when their data was last updated. Next, we infer TypeScript types from our schema using infer schema type. This gives us static types for free. We also define our user document and user module to type our module properly. What is the difference between them? User type gives you the pure shape of the data in your schema, just the fields and their types good for TypeScript definition. User document represents a full Mongoose document based on user type. Think of it as one individual user record. Last one is user module. It represents the entire user's collection. This is the user class itself. When using hot reloading, like in Next.js, module might get re-registered. This line prevents the app to overwrite module once compiled. It means if you do change in the module, you need to restore your server to see effects. Now, the star of the show, the portfolio schema. This schema ties everything together. Let's start with user ID field. This links the portfolio to the user who owns it. This field is a string that's required and indexed. It stores the unique identifier of the user who owns the portfolio. Indexing it allows us to quickly retrieve all portfolios for a specific user, which is essential for multi-user apps like this. The name is a required string field that also has an index. This field is used to label or title the portfolio. The template ID is an object ID that references another collection, specifically the template module. It links each portfolio to a specific visual layout or a template. It's required, ensuring that every portfolio has a defined style. The slug is a required, unique, and lowercase string that acts as the portfolio's public URL identifier. It also includes validation to ensure that the slug contains only lowercase letters, numbers, and hyphens. This makes URLs clean and SEO friendly. This field embeds a full portfolio profile schema, which includes the user's name, title, bio, email, photo, and social links. It's a required object and essentially powers the visible personal section of the portfolio. This schema defines the core personal identity fields for the portfolio. The name is a required string that stores the user's full name. It's trimmed for clean input and has a max length of 100 characters. The title is a required field that describes the user's professional title, for example, full stack developer. It has a max length of 200 characters and it's trimmed for consistency. The bio field is a required trimmed string of up to 1000 characters that lets the user describe themselves, their background, or their mission. Location, another required field that captures the user's city, country, or region. Maxed length 100 and trimmed to keep formatting clean. Email, this is required and validated using a regular expression to ensure it's a properly formatted email address. The value is also converted to lowercase and trimmed. Phone, an optional string for a phone number. It's trimmed, but there's no specific format validation, which you could add later for international formats. Website, this optional field lets the user link their personal or professional website, trimmed for consistency. Profile photo stores the URL of the user's avatar or profile picture. It's optional and trimmed, great for displaying a professional image. Social schema. This is an array of linked accounts like LinkedIn, GitHub, Twitter, and so on. Each item has platform, the name of the platform, and URL, a validated link to the profile. Skill schema refers to what you know. This schema represents individual skills, categorized and rated by proficiency. Name: the actual skill name, like React, Node.js, or Docker. It's required and trimmed. Category: this is required and must match one of a predefined list of categories, like Frontend, Backend, Full Stack, DevOps, Design, or Database. It lets you group skills logically for filtering or UI display. Proficiency: also required and must be one of beginner, intermediate, advanced, or expert. This lets the user indicate how confident or experienced they are in the skill. Level: an optional number from 1 to 5. It can be used for visual progress bars or rating circles. Certification schema refers to what you've achieved. This schema tracks verified qualifications or courses such as AWS certifications or bootcamp completions. Name: the title of the certification, like AWS Certified Developer, required and trimmed. Provider: the name of the organization that issued the certification. For example, Amazon, also required and trimmed. Issue date: an optional date field for when the certification was awarded. Expiry date: if the certification has an expiration, like security or cloud certifications. Big tracks when it becomes invalid. Credential ID: an optional string that can store a unique credential ID for verification purposes. Credential URL: a trimmed, validated URL field that links directly to the certification. Experience schema refers to what you've done. This schema is designed to mimic our resume's work experience section, with full structure for displaying timeline, roles, and contributions. Title: the job title, like Frontend Engineer or Tech Lead, required and trimmed, max 200 characters. Company: the name of the company or organization, required, trimmed, max 200 characters. Location: the location of the job. It can be remote, city, country, and so on. It's required and trimmed. Start date: the date of the job began. It's required. End date: it's optional. If the user left the job, this records when. If empty and is current is true, the role is ongoing, is current, or Boolean indicating whether this job is ongoing, defaults to false, description or required detailed overview of the job, responsibilities, and context, maxed 1000 characters and trimmed, achievements, an optional array of strings describing standout accomplishments, for example, improved loading time by 10%. Each one is trimmed and maximum 500 characters. Technologies, optional array of string listing the tech tools used during the job, like TypeScript, MongoDB, AWS, and so on. Project schema. This schema defines the structure and validation rules for documents in a project collection, typically used for a portfolio or a project showcase. Title must be a string, must be provided, removes white space from both ends, limited to 100 characters. Description describes the project in detail, limited to 1000 characters. Thumbnail URL for the project's thumbnail image. Not required, has a default image URL fallback if not provided. Technologies an array of strings. Each string represents a technology used, for example, React, MongoDB, and so on. Each entry must be trimmed and up to 100 characters. Demo URL. Optional field for a link to a live demo of the project. GitHub URL. Same validation as demo URL. Expected to link to the source code. It can be GitHub, GitLab, or another one. Is featured. Flag to mark if a project should be highlighted in a featured section. Defaults to false. Completed date. The date the project was completed. Can be used to sort projects chronologically. Portfolio settings schema refers to your portfolio settings. The portfolio settings schema defines how a user's portfolio behaves, looks, and who can access it. These settings give each user the power to personalize their portfolio and control its visibility. Is public. This field controls whether the portfolio is publicly visible on the internet. If set to true, anyone can view it without restrictions. The default value is true, encouraging users to showcase their work by default. Allow comments. This field determines if visitors are allowed to leave comments on the portfolio. When true, it enables interaction and feedback on portfolio projects or a blog post. The default contact info. This setting decides whether contact information like email or social links should be displayed publicly. Custom domain. This optional field allows users to connect their own custom domain. The value is trimmed to remove extra spaces and limited to 100 characters for safety. This adds a professional touch to the portfolio. SEO title. This field defines the portfolio's SEO title. The text that appears in search engine results or browser tabs. SEO description. This field allows users to write a short description for SEO purposes. It helps improve search ranking and click-through rate by summarizing what the portfolio is about. It is also trimmed and limited to 100 characters to follow SEO guidelines. Status. This is a string enum with 3 possible values: draft, published, and archived. By default, it starts as draft. View count. This is a number. It represents how many times the portfolio page has been viewed. When a new portfolio is created, its view count starts at 0. Timestamp through adds created at and updated at to every document. To object and to JSON, virtual through includes virtual fields to the output. We are creating a text index on 3 profile fields: name, title, and bio. This allows us to perform full text search. For example, if a user types React Developer in a search bar, we can use MongoDB's text search to find matching portfolios. These indexes optimize sorting. For example, if we want to display the newest portfolios first, we can sort by created at in descending order. Same for updated at and view count. This helps speed up queries like most viewed portfolios. This is a pre-save hook, meaning it runs before the document is saved to the database. If there's no slug provided, but the user has a name, we automatically generate a slug. This makes URLs cleaner and SEO friendly. This second hook also runs before a save, and it ensures that the slug is unique. If the slug already exists, we append a number to it. Here, we use infer schema type to automatically extract the correct TypeScript tag from our schema. That way, we get full type safety and auto-completion in our code base. Finally, we export our module in a safe way. If the module already exists, which can happen during development with hot reloading, we reuse it. Otherwise, we create a new one. This avoids duplicate module errors in Mongoose. Now, let's create the Mongoose schema for the template collection. Every template must have a title with trim spaces, lowercase it, and limited to 100 characters. Same idea for description. It required cleaned up and maximum 500 characters. We need at least one tag. Tags are used for filtering and search. A thumbnail is required. It must be an image, URL ending in PNG, and so on. We specify the main font used in the template, like Inter or Poppins. Primary color must be a valid 6-digit hex code. Secondary color 2. Is this template premium? Defaults to false, meaning it's free unless specified. Status can only be active or inactive. The default value is active. We automatically track when each template is created or updated. We set up indexes to make searching and sorting faster. by title, description, status, and date. Before saving, we clean all tags, removing spaces and making them lowercase. Here, we use infer schema type to automatically extract the correct TypeScript tag from our schema. That way, we get full type safety and auto-completion in our codebase. Finally, we export the module. This lets us use template module.find function and template module.create function as well, and more anywhere in our app. Now it's time to create the schema for contact collection. First, we define a portfolio field which stores a reference to a related portfolio document using its object ID. This sets up a relationship between the contact message and the portfolio it belongs to. The name, email, subject, and message fields are all required strings. Each one is trimmed, lowercase, and has a maximum character limit for validation. For email, we also provide a custom validator using a regular expression to ensure the format is correct. The status field uses an enum with 3 possible values: unread, read, or archived, and defaults to unread. We enable timestamp true in the schema options, which automatically adds created at and updated at fields to every document. We add 2 indexes to improve database performance. The first one ensures no duplicate contact messages are sent from the same email for a single portfolio. The second index speeds up queries by status and sorts them by created at in descending order. We also include a pre-save hook. Before saving a contact message, we strip out any HTML tags from the message content to prevent injection of tags or unwanted formatting. Finally, we use infer schema type to extract a full TypeScript type from the schema. This gives us strong typing across our code base and enables auto-completion. We also define a hydrated document and a contact module type for use with Mongoose. To safely export the module, we check if it already exists in Mongoose internal registry. If not, we create and register it. Alright, let's talk about the repository button. The repository button is a software design button used to abstract the data access layer. Instead of calling module.find function or module.save function directly in your services or controllers, you wrap all that database logic inside a reusable class. Why? It separates concerns. Your business logic won't be tied to the database logic. It improves testability. You can easily mock your repository in tests. It centralizes data access logic, making it reusable and easier to maintain. Now, let's create first an abstract class. An abstract class in TypeScript and many other object-oriented languages is a class that cannot be instantiated directly. It serves as a blueprint for other classes. You define common logic and structure in the abstract class, but you expect subclasses to provide specific implementations if needed. Why use abstract classes? To define shared logic and structure. Example, common methods and properties. To enforce or contract that all subclasses must follow. To prevent direct usage, you only want child classes to use the base. We are creating a special kind of class called an abstract class named base repository. This class is generic, meaning it works with any type of data. In this case, any Mongoose document represented by T. The abstract keyword means you cannot create an instance of this class directly. Instead, other classes will extend it and use the shared logic inside it. The T extends document. Port means this class works with any type T as long as it's a Mongoose document, which means it has MongoDB data and behavior. We are declaring a property named module inside the class. This module will hold a Mongoose module object, which is what we use to talk to the database, like creating, reading, updating, and deleting documents. The protected keyword means this property is hidden from outside the class, but available to this class and any classes that inherit from it. It represents a hidden variable called module to store the database module. So our class and its child classes can use it safely to access the database. This is a special function called a constructor. It runs automatically when we create or instantiate a new object from this class. We are asking whoever uses this class to give us a module, a Mongoose module, and we store it inside the class. The line this.module equal module means store the given module in our class module property so we can use it later. We make a reusable function to create and save a new item in the database. It takes a piece of data as input. Partial T means the data is optional or incomplete. Example, if T is a user, this could be name John without email or password property. We create a new Mongoose document using the module passed into the class. This .module is like saying use the specific database collection I'm working with. Example, user, product, and so on. Then saves the new document to MongoDB and returns the saved document. In this method, we created an asynchronous function called findById that takes an ID as input or string and returns either a matching document of type T or null if not found. It uses Mongoose findById method to search the database for a document with that ID. calls .exec function to execute the query and or wait for the result before returning it. In this method, we define an asynchronous function called find1 that takes or filter a query object based on the Mongoose filter query and returns the first document that matches the filter or null if no match is found. It uses Mongoose find1 function to search the collection, .exec function to run the query, and await to pause execution until the result is returned. In this method, we define an asynchronous function find that retrieves multiple documents from the database. It accepts or filter an optional option like sorting, limiting, and pagination. It uses this .module.find function to perform the query, passing the filter null for fields projection, and option to customize the query. Then it calls .exec function to execute the query and awaits to return the resulting array of documents. In this method, we define an asynchronous function, the find with pagination method that retrieves a paginated list of documents from the database by applying an optional filter, sort, order, and pagination parameters, page, and limit. It calculates how many documents to scan based on the current page, then concurrently fetches the requested page of results and the total number of matching documents using promise.all. Finally, it returns the paginated data along with metadata including the total count, current page, and total number of pages. The update method updates a document in the database by its ID using the provided update data. It uses find by ID and update to locate the document and apply the changes with the new true option, ensuring that the updated version of the document is returned. The method returns the updated document if found or null if no document with the given ID exists. The update1 method finds the first document that matches the given filter and updates it using the provided data. It uses find1 and update with the new equal to true option to return the updated version of the document. If a matching document is found and updated, it returns the updated document, otherwise it returns null. The delete method. This method deletes a single document from the database by its ID. It uses find by ID and delete to locate and remove the document with the given ID, returning the deleted document if it existed, or null if no matching document was found. The same way, delete many method deletes multiple documents that match a given filter. It calls delete many on the module with the filter, which removes all matching documents, then returns an object containing the count of how many documents were deleted. The count method. This method counts how many documents match a given filter. It uses count documents on the module with the filter and returns the total number as a promise. Exist method. This method checks if at least one document exists that matches a specified filter. It queries the database with find one, selecting only the ID field, and returns true if a matching document is found or false otherwise. Now let's define the user repository. Here we define our new class user repository class that extends the generic base repository with the user document type, meaning it inherits all the generic database methods like create, find by ID, and so on. The constructor calls super that takes as argument user to pass the Mongoose user module to the base repository, setting it up to perform database operations specifically on the user collection. This method takes a clock ID string and returns the first user document that matches this clock ID by reusing the inherited find one method from the base repository, effectively abstracting the query logic. This method updates a user document based on the provided clock ID and portion update data. It calls Mongoose find one and update directly on the user module. This method deletes a user document matching the given clock ID by using Mongoose find one and delete on the user module, returning the deleted user document if found or null otherwise. This method finds and returns the first user document with the matching email by reusing the base repository's find_one method. This method updates a user document by its MongoDB ID using the base repository's update method, passing the ID and the partial update data to perform the update and return the updated document. We create and export a single shared instance of user repositories class, allowing other parts of the app to import and use the same repository object to perform user-related database operations. Now, the template repository. Here, we define a class named template repository class. This class will group together all logic related to accessing and modifying template documents in your database. With this class, we extend base repository. We are inheriting from a generic class-based repository. We are passing template document as the type to base repository, which means all the logic inside base repository will now expect and return data in the shape of a template document. With the constructor method, we define what happens when template repository class is created. Find all with filters retrieves templates, applying optional filters such as status, premium flag, tags inclusion, and text search. It builds a query object accordingly and uses pagination to return a paginated list of matching templates with metadata like total count and pages. We initialize an empty MongoDB query object. Filter query template document is a Mongoose type that helps TypeScript understand this query will be used to filter template document items. If filters.status is provided, example, publisher, draft, and so on, it adds it to the query. If the premium filter is defined either true or false, it adds it to the query. If a non-empty array of tags is passed, it filters the templates whose tags fields includes at least one of the provided tags. Uses MongoDB's in operator. If a search string is passed, it uses MongoDB's full text search via the text operator. Assumes a text index is already defined on the module, example, on title, description, and so on. Calls a method find with paginations likely defined in base repository to run the build query on the database. This duplicate template method is a function to duplicate an existing template in your database. It takes a template ID as a string and returns a non-duplicated template document or null if not found. Here we fetch the original template from MongoDB by ID and use len function to return a plain JavaScript object instead of a Mongoose document. If the template does not exist, exit early and return null. Start with a default title like my template copy, Check if the duplicate title already exists in the database. If it does, increment the number like my template copy 2, my template copy 3, and so on. This loop ensures each duplicated template has a unique title. Then we create a new template using the values from the original one. The only changes are the title is modified and unique. The status is set to inactive by default. Then we save the new duplicated template to MongoDB. Next, let's create Portfolio Repository class. We are creating a class named Portfolio Repository class. This class inherits from base repository. We are passing them in the type portfolio document so this repository knows what kind of documents it deals with. The constructor is called when you create an instance of the class. Super portfolio calls the constructor of the parent class, which is base repository, and passes it the Mongoose module portfolio. We are creating a method called find_by_slug to retrieve a single portfolio by its slug, including its related template data. We define then an asynchronous method named find_by_slug. It takes a slug string as input. It should return a portfolio document or null if not found. I'm using then Mongoose find_one to look for a single document where the slug field matches the given input. .populate template ID tells Mongoose to automatically fetch the full template document linked by the template ID field. So instead of just getting the template object ID, you get all template details. If found, return the full portfolio document. If not found, returns null. But if any error happens, example, database connection issue, it catches the error, then throws a custom error message with either the real error message or a fallback unknown error. This function fetches a list of portfolios that belong to a specific user. I define an asynchronous method named find_by_user_id. It takes user ID, which is the ID of the user, filters, which is optional filtering, sorting, pagination options. I create and export a TypeScript interface called Portfolio Filters, which defines a set of optional filters and options for querying portfolios. The status field allows filtering by portfolio status, limited to draft, published, or archived. The template ID is an optional string used to filter portfolios by a specific template. The search field enables keyword-based searching, likely matching text fields such as name or title. The sort by field allows specifying which fields to sort the result by such as created at, updated at, view count, or name, and sort order determines the sort direction. It can be AXC for ascending or DESC for descending. Finally, page and limit are optional pagination parameters to control which page of result to return and how many items per page to include. Also, define and export a TypeScript interface named Portfolio Response, which represents the structure of a response returned when fetching a paginated list of portfolios. The portfolios field is typed as unknown, meaning it can hold any kind of portfolio data. The total field indicates the total number of portfolio items available in the database that match the applied filters. The page field represents the current page number being returned, while the limit specifies how many portfolio items are included per page. Lastly, total pages is calculated from total and limit and tells how many pages of results are available overall. This structure is useful for client-side pagination. Enable the frontend to know how much data exists and how to navigate through it. Now, I am implementing a server-side function to fetch a filtered, sort, and paginated list of portfolios for a specific user, handling all logic within a try block to catch potential errors. First, we destructure filters to extract query parameters such as status, template ID, search, sort by, sort order, page, and limit, providing defaults for sorting and pagination. I then built a MongoDB query object starting with the user ID to ensure only the requesting user's portfolios are returned. If status or template ID are present, they are added to the query. If a search term is provided, we use a OR clause with regex to match it against profile.name, profile.title, profile.bio, and slug, allowing case-insensitive partial matching. I then count the total matching documents for pagination metadata. A sort object is constructed based on sort by and sort order, giving special handling if sorting by name. After calculating the escape value for pagination, we execute the MongoDB query using portfolio.found, populating the related template ID field from the template module, and applying sorting, skipping, and limiting. Finally, the function returns an object containing the result portfolios, pagination info, and total count. And if any error occurs during the process, it throws a descriptive error message. This find all function retrieves a paginated list of public and published portfolios based on optional filter parameters. It first extracts page and limit values from the filters object using default values if not provided. It then builds a MongoDB query to include only portfolios where the status is published. and the settings dot is public flag is true. It calculates the total number of matching documents using count documents. Prepares a sort object which is currently empty but ready for future sorting logic. And calculates how many documents to skip based on the current page. It then queries the database using portfolio.find, populates the template ID fields with data from the template module. Applies sorting, skips the appropriate number of documents, and limits the results to the given limit. Finally, it returns an object containing the portfolios, the total count, current page, limit per page, and total number of pages. If an error occurs, it throws a clear and descriptive error message. The increment view count function increases the view count of a specific portfolio by 1 using its ID. It uses find by ID and update to locate the portfolio in the database. And apply the inc operator to increment the view count field. The new true option ensures that the updated document is returned. Additionally, it populates the template ID field with the name, thumbnail, and category of the associated template for easier access. The function then returns the updated portfolio document or null if not found. If any error occurs during the process, it throws a descriptive error message. The get portfolio by ID function retrieves using its ID and the user's ID to ensure ownership. It uses find one to locate the document that matches both ID and user ID, helping enforce user-level access control. The function also populates the template ID field to include full template data in the result. If a matching portfolio is found, it returns the document, otherwise, it returns null. If an error occurs during the query, it throws an error with a descriptive message. The get portfolios function retrieves all portfolios for a specific user, applying optional filters such as status, template ID, search, and pagination options such as page and limit. It accepts two parameters, user ID, which is a string identifying the user, and filters, which is an optional object of type portfolio filters, defaulting to an empty object. Inside the function, it simply returns the result of calling this dot find by user ID, which takes user ID and filters as params, which means it delegates the logic to another method named find by user ID that handles the actual database query, applying filters, sorting, and pagination, and returning a structured response containing the list of portfolios and pagination metadata like total, page, limit, and total pages. The get public portfolios function retrieves all public portfolios from the database while applying optional filters such as status, template ID, search, and pagination details. It accepts a single optional parameter filters of type portfolio filters, which defaults to an empty object if not provided. The function then calls and returns the result of this dot find all, which is a method responsible for executing the actual database query based on the provided filters. Get portfolio by slug. This function fetches a public portfolio based on its slug, which is a user-friendly part of the URL. First, it tries to find the portfolio using the find by slug method. If it exists, it increases the portfolio's view count by calling increment view count. Finally, it returns the portfolio. This function is useful for displaying a public portfolio page and tracking how often it's viewed. Is slug taken? This function checks whether a given slug is already being used by another portfolio in the database. If exclude ID is provided, it excludes that specific portfolio from the check, which is useful when updating an existing portfolio. It returns true if the slug is taken or false if it's available. This generate unique slug function is used to create a unique SEO-friendly strings identifier called slug. It takes two arguments, base name, which is a required string, and exclude ID, an optional ID used when updating an existing item to avoid falsely detecting a slug conflict with itself. The function first turns the base name into a clean URL style string using the generate slug helper and stores it in base slug. It then sets slug to that base value and stores a counter at 1. In the while loop, it checks if the current slug is already taken in the database using is slug taken, which may check if an existing record already uses that slug, except the one with exclude ID. If it's taken, it adds a number to the end and keeps trying until it finds a slug that is not already used. Finally, it returns the unique slug, ensuring each item has a clean and unique URL-friendly identifier. The validate slug availability function is used to check if a given slug is valid and available. It takes two arguments, slug or required string, and exclude ID, an optional ID used when editing an existing item so it does not falsely flag its own slug as taken, and returns a promise that resolves to an object describing the result containing is valid, a boolean indicating whether the slug is acceptable, message optional, or string explaining why the slug is invalid if it's not. First, the function checks if the slug is in the correct format using the validate slug helper. The validate slug function is a TypeScript export that returns a boolean indicating whether a given slug string meets specific criteria for a valid URL slug. It defines a regular expression that ensures the slug starts with one or more lowercase letters or digits and may be followed by additional groups prefixed by a hyphen. Without allowing uppercase letters, spaces, special characters, or consecutive, leading, trailing hyphens. After testing the input string against this regex using slug regex.test, it further checks that the slug's length is between 3 and 50 characters. The final return statement uses logical AND operator to combine both format and length checks, ensuring the function only returns true when both are satisfied. If the format is wrong, it returns an object saying the slug is not valid, along with a helpful error message. If the format is OK, it then checks if the slug is already used by another item in the system using a slug taken function. Again, optionally ignoring the item with exclude ID. If it's already taken, it returns is valid false with a message saying it's taken. If everything is fine, correct format and not used, it returns is valid true, meaning the slug is valid and available to use. The create portfolio function is an asynchronous method that takes portfolio data, creates portfolio request, and returns a promised portfolio document. You defined a TypeScript interface called create portfolio request that outlines the structure of the data required to create a portfolio. It includes fields like user ID, name, and template ID as required strings, while slug is an optional string for custom URLs. The interface also requires structured objects such as profile of type portfolio profile, skills, and array of skill. Certifications, an array of certification including the possibility of being empty. Experiences, projects, and settings of type portfolio settings. This interface ensures type safety and consistency when handling portfolio creation requests in your application. I define a TypeScript interface called Portfolio Profile that describes the structure of a user's profile information for a portfolio. It includes required fields such as name, title, bio, and email, which captures the user's basic identity and contact details. It also includes optional fields like location, phone, website, and profile photo, allowing flexibility for users to provide as much or as little information as they prefer. Lastly, it contains a social media field, which is an array of social media objects, presumably links or handles for platforms like LinkedIn, Twitter, GitHub, and so on. This interface ensures that any profile object in your app follows a consistent typeset format. The skill interface represents an individual skill in a user's portfolio. Each skill includes a name, example, React, a category such as Frontend, Backend, or Design to group it by discipline. a proficiency string to describe skill level like intermediate or expert, and an optional level as a numeric value which could be used for visual indicators like progress bars. The certification interface captures professional certifications the user has earned. It includes the certification name, the provider or issuing organization, and optional fields like issue date, expiry date, credential ID, and credential URL. These optional fields allow users to validate their credentials and add credibility to their profile with verifiable information and timelines. The experience interface defines a user's professional or freelance work experience. It contains the title, which is the role, the company, location, start date, end date, or boolean is correct to indicate ongoing roles, or description of responsibilities, a list of achievements, and a list of technologies used. The project interface represents individual portfolio projects. It includes title, description, a thumbnail image, the technologies used, and links to a demo URL and GitHub URL. The is featured Boolean highlights important projects and completed date optionally records when the project was finished. This interface helps showcase to users practical experience in project work in a compelling way. The portfolio settings interface stores configuration options for a user's portfolio visibility and behavior. It includes flags like is public, allow comments, and show contact info, as well as optional fields like custom domain, SEO title, and SEO description for customizing the portfolio's domain and improving search engine visibility. This enables users to personalize how their portfolio is presented to the public. Now, we can import the Create Portfolio Request interface and continue to implement this function. It first checks if a slug is provided. If not, it generates one using this .generate unique slug function. It then validates the slug with this .validate slug availability. And if the slug in use generates a new one. A new portfolio object is then constructed using the data from portfolio data with default values like status draft and view count 0. Finally, the portfolio is saved to the database using portfolio.save function, and the saved result is returned. If any error occurs during the process, it's caught and reframed with a descriptive message. The update portfolio function is an asynchronous method of portfolio based on given user ID and portfolio data. Here, I define a TypeScript interface called update portfolio request, which is used when updating an existing portfolio. It extends portion create portfolio request, meaning all properties from create portfolio request become optional in this interface, except for the ID field, which is required here to identify which portfolio is being updated. I also add a custom optional field status, which can be either draft, published, or archived, allowing you to manage the portfolio's lifecycle or visibility. Now we can import this interface here and allow this function to return a promise, portfolio document, or null. It begins by preparing an update data object. And if a new slug is provided, it validates its availability using this .validate slug availability. If the slug is invalid, it throws an error. Otherwise, it adds the slug to the update payload. It then conditionally maps other fields from portfolio data such as template ID, profile, skills, certifications, experiences, projects, settings, and status into update data. The function then updates the portfolio in the database using portfolio.findOne and update function, ensuring the document belongs to the specified user ID and returns the updated and populated portfolio. If any error occurs, during this process, it throws a formatted error message. The duplicate portfolio function is an asynchronous method that duplicates an existing portfolio for a given user ID and portfolio ID, returning a promised portfolio document. It starts by fetching the original portfolio using this .getPortfolioById function and throws an error if the portfolio does not exist. It then generates a unique slug for the duplicate via this .generateUniqueSlug function. The function proceeds to deep copy and clean up various fields from the original portfolio like social media links, skills, certifications, experiences, and projects, ensuring optional or null values are handled appropriately. Our new data object is assembled, defining fields like the name or pending copy and reusing relevant information. Finally, it creates and saves the duplicated portfolio using this .create portfolio function that takes duplicate data and returns the newly created portfolio. If any error occurs, it is caught and reflown with a detailed message. The delete portfolio function is an asynchronous method that deletes a portfolio based on the provided user ID and portfolio ID, returning a promise void. It attempts to locate and delete the portfolio from the database using portfolio.find_one and delete function, ensuring that the document belongs to the given user. If no matching portfolio is found, either because it does not exist or the user lacks permission, it throws an error indicating that the portfolio was not found or access was denied. Any other errors encountered during the operation are caught and rethrown with a descriptive message. The publish portfolio function is an asynchronous method that updates the status of a portfolio to published for a given user ID and portfolio ID, returning a promise portfolio document. It performs the update using portfolio.find_one and update function, ensuring the portfolio belongs to the specified user. The method also populates the template ID field with selected details like name, thumbnail, and category. If the portfolio is not found due to an invalid ID or unauthorized access, it throws an error indicating the issue. Any other errors encountered during the process are caught and rethrown with a descriptive error message. The getPortfolio URL function is a simple synchronous method that takes a slug as input and returns a string representing the portfolio's URL path. It constructs the URL by embedding the provided slug into the path /portfolio/slug, which is likely used to route users to a specific portfolio page based on its unique slug. GetPortfolio Preview URL is a synchronous method that generates a preview URL for a portfolio based on its slug. It takes a slug string as input and returns a formatted string in the form of /preview/slug. This is useful for linking to or rendering a preview page for a specific portfolio without hard coding paths throughout your app. Count published. This asynchronous function counts how many portfolios a given user has that are marked as published. It uses portfolio.count documents function with a filter on both user ID and status and wraps the operation in try-catch block to handle potential database errors. If any error occurs, it throws a detailed error message. This function is useful for analytics, dashboard displays, or enforcing publishing limits per user. At the end of this portfolio repository, I create and export a singleton instance of the portfolio repository class by assigning it to a constant called portfolio repository. This means I'm instantiating the class once and making that instance available for use throughout the application by importing it. The contact repository class. I create this class that extends base repository and is specifically designed to handle database operations for contact messages. In the constructor, I call super that takes contact module to pass the Mongoose module to the base repository. Exists for portfolio email. This asynchronous method checks whether a contact message already exists in the database for a given portfolio ID and email. It performs a find one query using Mongoose and returns a boolean true if a matching record exists, otherwise false. This is useful for preventing duplicate contact submissions, spam, or ensuring a user only sends one message per portfolio. Save contact message. This method saves a no contact message to the database. It receives a data object containing contact details like portfolio, name, email, subject, and message. Create some new instance of the contact module with that data and saves it using mongoose.save method. It returns the saved contact document, making it suitable for confirmation messages or further processing. At the end, I instantiate and export a singleton instance of contact repository class as contact repository. This allows to reuse this single instance across the application for managing contact messages in a clean and consistent way. How to set up MongoDB Atlas for your app. First, go to mongodb.com. Then either log in or create a new account. Next, click Create New Project and give your project a meaningful name. After that, you'll create a MongoDB cluster. A cluster is a group of MongoDB servers working together to provide scalability, high availability, and fault tolerance for your database. MongoDB Atlas offers different cluster types, including free and paid plans. The free cluster, which is MNO, is perfect for development, testing, and learning, but it comes with limitations like slower performance, shared not dedicated infrastructure, limited region and scaling options, no custom backups or advanced monitoring, basic access control, which means less security. If hacked, you risk data loss. For production apps or serious development, you should choose a paid cluster like M10, which offers dedicated hardware, automated backups and monitoring, more regions, and advanced features like fine-grained access control. I personally use an M10 cluster for 10-minute portfolio.app, and I also share best security practices to keep your database safe in production. Choosing your cloud provider and region. Atlas lets you deploy your cluster on any of the three major cloud platforms: AWS, GCP, Azure. Choose the provider based on where your app is hosted, your preferred ecosystem or budget. Each provider offers multiple regions worldwide. Pick a region closest to your users or servers to reduce latency. Free clusters usually restrict you to a limited set of regions, often AWS, so you'll likely stick with the default options there. Paid clusters give you full freedom to pick provider and region. Creating and securing your cluster. Once you select your cluster, click Create Deployment and proceed to configure the connection. Atlas requires you to specify IP addresses allowed to connect to your cluster for security. By default, it adds your current machine's IP address so you can connect during development. This means only requests from whitelisted IP addresses can access your database. In production, you will need to whitelist the IP address of your deployed app or cloud provider. If you are using VPC, peering, or private endpoints on AWS, GCP, or Azure, you can get static IP addresses to whitelist. For platforms like Versor or Netlify, which don't provide static IP addresses yet, there are alternative security methods I can share. Just ask in the comments. Creating database users. Next, create a database user with appropriate access. Usually admin for development. You can keep the default credentials or customize them. Atlas provides a connection string or special URL your app uses to connect to the database. First, select Mongoose and install the Mongoose package in your project. The connection string contains host name, ports, database name, credentials, and options. Copy this string, add, and set it as the value of a new environment variable called mongo underscore URI in your .env file. Append your target database name to the connection string. You can create multiple databases for different environments, such as dev for development, test for testing, prod for production. MongoDB Compass and VS Code extension. MongoDB Compass is a key tool to visually explore your data. Download it from the official site for your operating system. The MongoDB for VS Code extension lets you manage your databases directly inside Visual Studio Code without switching to Compass or the terminal. Install it from the VS Code Marketplace. Then add your cluster connection string. to start querying and managing data. Atlas SQL enables you to query MongoDB collections using SQL syntax. Even though MongoDB is a NoSQL database, this is great for data analysts and non-developers who prefer SQL. Integration with BI tools, quickly exploring data without writing complex MongoDB queries. In your application, create a database.ts file, example, inside a lib folder. This function checks if Mongo underscore URI is defined in the environment and throws an error if missing. Uses a custom login utility devlog that outputs warnings and errors only during development, keeping production logs clean. defines a Mongoose cache interface and uses a global variable to catch the Mongoose connection and promise, preventing multiple connections during hot reloads or serverless function executions. Protecting APIs with Clerk token. In this section, we will implement Clerk authentication and authorization guards to protect your APIs from unauthorized front-end requests. First, set up Clerk. Go to the Clerk website and log in to your account. From your dashboard, create a new application. Give it a name. Select relevant authentication providers. GitHub and Google are common choices for production since they are easy to set up. Click Create Application and follow the setup instructions. In this example, we are using Next.js. So, install Clerk dependencies. And confirm your Clerk version. Here we are using version 6. Add your Clerk API keys to your .env file. Middleware is code that runs before a request reaches your route handler. It's useful for tasks like authentication, authorization, login, and request validation. Clerk middleware automatically handles user authentication, session validation, and authorization checks. We will create an off-guard helper function to protect routes. The off-guard function works like a gatekeeper for APIs or server functions. What it does, it checks if the user is logged in. It uses auth function from Clerk to get user ID and session ID. If user ID is missing, then it returns 401 and overrides it. Then it fetches user details. We are going to use Clerk client.users.getUser function to get the full user object, including private metadata like roles. You never heard about private metadata. Let me explain. In Clerk, every user object has a few metadata fields you can use to store custom information. We have metadata like private metadata, public metadata, and unsafe metadata. Public metadata is used to store data that is safe to share with the frontend, like a user's theme, preferences, or onboarding progress. Private metadata is used to store data that is kept secure on the server only, like user roles, permissions, or organization IDs. Unsafe metadata is used to store data that the frontend can read and write directly. So it's good for temporary values but must always be validated on the backend. As a result, to store our user role, we'll use the private metadata. And then to access the role of the user, it will be accessible from private metadata.role. Great. Now back to our off-guard file. We do an optional admin check. If require admin is true, verify user.private metadata.role is admin. If not admin, return 403 forbidden response. Otherwise, return user ID, section ID, and user object. Every time we use try catch statement, we handle error handling like that. If an error occurs, example, network or API error, logs it and returns 500 internal server error. Now let's talk about clock session token. A clock session token is a secure, short-lived credential proving who the user is when making backend API requests. We are going to customize the session token. In Clock Dashboard, go to Configure, then go to Customize Session Token. And here, we'll be using both private metadata and public metadata. But as you can see on the right, we can only add the public metadata and unsafe metadata. Why? Because this comes down to how Clock guarantees security boundaries. Session tokens, GWTs, are exposed to the client, but private metadata is designed to be server only. Clock deliberately prevents it from being included in session token, so you don't accidentally leak sensitive values like role or internal IDs. That's why Clock only allows public metadata and unsafe metadata if you explicitly want it to be injected into the JWT. So in short, here we can add public and unsafe metadata only, but since we are not going to use unsafe metadata, I just add public metadata, and regarding private metadata, it is already added by Clock itself. After adding metadata, we need to add role types to avoid TypeScript error. So, to strongly type the role field, create a global.d.ts file in your project root. In a TypeScript project, the extension d.ts is used for type declarations that are globally available without needing to import them everywhere. A type role can be either admin or user. This type will be available throughout your project. We'll now write middleware to verify authentication, to check admin roles for certain endpoints, to handle public and private routes. The middleware accepts two arguments of or Clock's function to get the signed-in user, request or Next.js next request object. We create a default next response.next function to allow the request by default. We get a Clock ID client instance using Clock Client SDK. we extract path name from request.next URL. Also, we call auth function to get the user ID. Afterwards, we do an admin check. If path starts with /API/admin, then this path requires the admin role. If not, admin return 403 for building response. To finish, we allow all other requests that do not require any auth token. In Next.js, API routes live in the app/API folder. You can structure routes as /API/admin/ for admin only, /API/public/* for APIs that do not require any auth token, and /API/webhooks/ for webhook handlers. We also need to implement user authentication check. If path does not start with /API/public or /API/webhooks or /API docs, the user is required. If no user ID, it means no authentication and return 401 unauthorized. Protect API with CORS. CORS stands for Cross-Origin Resource Sharing. It's a web security mechanism that controls whether a browser is allowed to make requests to a domain different from the one that served the current web page. For example, the frontend app of 10-minute portfolio runs on 10minuteportfolio.app, and the API backend runs on api.10minuteportfolio.app. When your frontend make requests to your backend API, it will throw an CORS error. Why? Because without CORS, by default, your browser, it can be Google Chrome, Safari, Firefox, you name it, blocks all frontend JavaScript from making requests to another domain, even if you deploy your apps in the same domain like 10minuteportfolio.app with different port or protocol. This is one of security measures provided by web browsers. Now, to fix that, when the frontend app 10minuteportfolio.app sends a request to the API backend server, which is api.10minuteportfolio.app, the browser sends first a request with method options called a pre-flight request to check if the server allows the real request. And if you do not set up CORS on your backend API, it will likely fail. So you have to set up CORS on your backend to allow which frontend app can have access to your API. For that, there is something called CORS headers that you need to set up. CORS headers are part of the CORS system. They are instructions that the server sends to the browser to tell it who can access the resource, with which methods, and under what conditions. They are not one single header, it's a family of headers that work together. Now, the thing is, Next.js is not a dedicated backend framework. It's a meta frontend framework with backend capabilities. What does it mean? It means, unlike backend frameworks like Next.js or Express.js that provide backend built-in libraries to handle all backend logic such as CORS, validations, CSRF, and more, it's up to you to implement all that logic in your Next.js backend API and create your own solid architecture. And that is exactly what I'm going to show you right away. So let's get back to our code editor. First, create a folder in lib folder called CORS, then a file called index.ts. Here, we will implement our CORS logic. First, create a main function called with Clerk Protection. This is a function to wrap API handlers so they have Clerk Protection automatically. The function takes two arguments. Request, this is the incoming HTTP request object from Next.js server layer. It contains request method, headers, URL, body, and so on. Second argument is handler. This is a function you pass in your actual API logic. It must take a next request and return either a synchronous next response or asynchronous promise next response. Then we retrieve the current course settings the middleware should use with get course config. This function return type is course config. Create then course config type in types folder. That's a TypeScript interface defining the exact shape of a course config object. It contains types for allowed origins, which is all allowed origins domains that can access the server. Allowed methods, which is HTTP methods that the server will accept in course requests. Allowed headers, which is lists HTTP request headers that the client is allowed to send. Allow credentials. If true, the server allows sending cookies or authorization headers in cross-origin requests. If false, credentials are blocked. Max age means how long the results of a course pre-flight request can be cached by the browser. Option success status is the HTTP status code to return for successful pre-flight option requests. Then, in the get course config function, let's start by copying all properties from the default course config constant into a new object. The spread operator ensures we don't mutate the original default. Default course config contains default value for course config. So just copy the course config type object and then edit values for each property. For allowed origins, we set an empty array, means no origins explicitly allowed by default. So in production, all requests will be blocked by default. For allowed methods, these are the HTTP methods we will let through course. Any others will be blocked. For allowed headers, these are the headers clients can send in their requests. Content type tells the server what kind of data the request body contains, whether it's JSON, form data, or X World Wide Web form URL encoded. Authorization sends credentials or tokens to authenticate the user. CSRF token prevents cross-site request forgery or tags. X requested with used by Ajax. Origin indicates the domain that initiated the request. Accept tells the server what content types the client is willing to accept in the response. Cache control tells the server or browser how to cache the request or response. Now, next is allow credentials. It allows cookies, session tokens, or authorization headers to be sent cross-origin. If this is true, access control allow origin must be a specific domain. Max age. Here we define 24 hours. Option success status. We set HTTP 200 for successful options pre-flight. Then we are going to set origin that we want to allow for development in production environment. So if it's production environment, usually means live users on your real domains. Read the allowed origins environment variable. Allowed origins is a string, a comma-separated list of domains. To get each domain, we need to split the string into an array of origins, then remove extra spaces around each origin. If process.env.allowed origins is undefined, skip and fall back to empty array. Finally, we store these allowed domains in config.allowed origins. If not production, basically when you are in development or test mode, allow requests from localhost addresses and ports commonly used during development. This ensures you can test your frontend locally without coarse errors. Return the final course configuration object for the current environment. This object will later be used to set the appropriate access control headers on responses. Once we are done with getCourseConfig function, let's get back to our main function then get origin and method from request frontend. Log the course check information, including method, origin, requested URL, and allowed origins. This is going to be useful for debugging why a request may be blocked in development. Also, handle pre-flight requests. So if method is options, because options requests are pre-flight requests sent by browsers. When the request is an options, it's handled by handle pre-flight request function. So let's implement this function. Declare a function named handle pre-flight request. This function responds to option requests sent by browsers before actual cross-origin requests. It takes arguments like request, which is the incoming HTTP request, config your course configuration object, and return next response, which is the response object that will be sent back to the browser. So what are we doing here? We get method, origin, and headers from frontend request. Then log pre-flight request details for debugging. Then check if the request origin is in your allowed list using is origin allowed function. If not allowed, return 403 forbidden immediately. Is origin allowed? Check whether a given request origin is allowed to access your API. It takes two arguments: origin, which is the value from the request origin header, allowed origins, and array of domains you've configured in course. Then returns true if the origin is allowed and false otherwise. If the request does not have an origin header, allow it. This prevents blocking requests from your own server. Otherwise, check if the request's origin matches one of the allowed origins. If yes, then allow the request. During development, always allow requests from localhost servers, even if they aren't in allowed origins. This makes local testing easier without editing course configuration constantly. If none of the above checks passed, then you can deny the request. RBAC to handle pre-flight request function after origin is allowed. We also need to allow the HTTP method sent by frontend request. If request method is valid and not included in config allow methods, return 405 method not allowed. Create a pre-flight response and send status code 200 with null as nobody is needed. Also, add all necessary CORS headers to the response using set CORS headers. This function adds all necessary CORS headers to an HTTP response. It takes as arguments response, the next response object to modify, origin, the origin header from the incoming request, config, your CORS configuration object. And returns the modified response. First, we assume all origins are allowed using asterisk wildcard. Case 1. If credentials are allowed and the request has an origin and it's in the allowed list, then use the specific origin in the header. Case 2. If credentials are not allowed, use asterisk. Case 3. Credentials required but origin not allowed. Then skip setting CORS headers and return the response immediately. Then set the access control allow origin header in the response. Set which HTTP methods are allowed for cross-origin requests. Also set which headers the client can send in cross-origin requests. Tell the browser how long it can catch the pre-flight response in seconds. If credentials are allowed, instruct the browser to send cookies or auth headers with the request. With very origin tells catches like CDNs that the response depends on the origin header, so it should not reuse the response for requests from other origins. At the end, return the response with all course headers applied. Great. Now in handle pre-flight request function, just return the response. And we can go back to the main function now. Here we are saying if real, request and origin not allowed, reject. Otherwise, execute the handler and add course headers to response. Then, handle both sync and async response. We are done with core setup. Now it's time to apply cores to APIs in the middleware.ts. At the beginning, add if path name starts with API. Then return with CORS protection and add the frontend request with an async function that might take the request if needed and should return the with CORS protection response. With that said, your Next.js API routes are safely protected. Protect API with CSP and headers. Security headers or HTTP response headers that add an extra layer of security to your web applications. They instruct the browser on how to behave when handling your site's content, requests, and resources. Some key security headers are Content Security Policy (CSP). It prevents attacks like XSS, cross-site scripting, and data injection. What is XSS? Cross-site scripting. XSS happens when an attacker injects malicious scripts, usually JavaScript, into a web page. Imagine you have a login page. If the attacker injects that script, the browser will execute it immediately, showing an alert pop-up, stealing cookies, or worse. This is called classic XSS attack. Now you configure a CSP header like this in your HTTP response. content security policy. Default SRC has value self. Script SRC has value self as well. What does this mean? Default SRC self allow content only from your own domain. Script SRC self only allow JavaScript loaded from your own domain files, not inline scripts. After setting this config in your app, what happens when the attacker injects the same script? The browser sees the CSP rule, script SRC self. Since this script is inline and not from your trusted domain, the browser blocks it automatically. Instead of running, you see a CSP error in the console like refused to execute inline script because it violates the content security policy directive, default SRC self. Result, the attack is neutralized. Data injection is when an attacker manipulates your queries or your commands. By adding SQL or NoSQL query in user input instead of real value. For example, since we are using MongoDB, let's say we have this login input and an attacker sent malicious JSON instead of normal values. What happens? NE operator means not equal. So in your backend, it becomes this. This matches any user in the database since both fields exist and are not null. If the first user is admin, the attacker is now logged in as admin without knowing the password. CSP is a browser-side defense. It controls what resources the browser can load and execute, like scripts, styles, images, fonts, frame, connections, and so on. It prevents XSS or malicious script injection from running in the browser. It does not prevent server-side attacks like SQL, NoSQL injection because CSP has no effect on the backend database. So in short, use CSP for browser-level defense for XSS and script injection. But make sure to implement input validation, query sanitization, and parameterization using Mongoose, strong schema, and zone validation on both client and server side for backend level defense, which is what we will see later in this video when building APIs routes. You can use timestamp if you want to move to that point or continue this video normally. Now let's see how CSP works in a Next.js app. Next.js allows you to define custom HTTP headers, including CSP. Inside the next.config.ts file, add async headers function. This is a Next.js feature in next.config.ts that allows you to set custom HTTP headers for specific routes. It returns an array of objects, each defining a route, which is source, and the headers you want to attach. The source field specifies which paths the headers apply to. This is about all our API's route, so add /API/ with regex parentheses to match whatever is inside API folder, then dot to match any single character except new lines, and finally asterisk means 0 or more times. The first header we are going to set is course headers, and you are going to say, we already set course config in the middleware. Why do we need to set CORS again here? Well, firstly, middleware overrides headers. It means no matter what headers you set here, your middleware has the last word. Secondly, sometimes I keep both. I use the middleware for dynamic checks to handle every request dynamically. And I use CORS headers in nest.config.ts for default fallback as static CORS applied at the HTTP response level automatically for matching routes. And thirdly, if something went wrong with the middleware, remember the exploit CVE 2025-29-927. And finally, as a backend developer, knowing all the way to protect your app is essential because security is not just a feature. It is part of your core responsibility. This is why companies do not hire junior backend or full stack developer, but only senior. But watching this entire video, you will understand these concepts practically since all backend frameworks are using it, whether it's Next.js, Express.js, or even other languages frameworks like Laravel, Django, and so on. Now, the first CORS header we'll set is access control allow origin. Here, I will say the value will be equal allowed origin in production, and in development mode, we are going to use local server. Then, for access control, allow methods value will be get, post, put, delete, patch, and options. For access control allow headers, we'll add content type for data type, authorization for auth token and credentials, CSRF token for CSRF, and so on. Then, for access control allow credentials, it should be true by default to allow you to set calls for a specific domain. Then, for very key add value origin. Now we are going to add more security headers. The first one is X content type options. This prevents browsers from trying to guess the MIME type of files. Let's suppose your server serves a file which has default type and content type text plain, but the file actually contains a script alert hacked. Some browsers, specifically older ones, may ignore the text plain MIME type and try to execute it as JavaScript. Results, attacker's script runs in the browser. This is called a MIME type sniffing attack. Now, when you add X content type options with value no sniff, browser must trust the content type header. In this case, text plain will be treated strictly as plain text, which means the JavaScript code is not executed. User sees harmless text instead of running malicious code. Another header is XSS Protection. This tells the browser to enable its built-in XSS filter. Instead of trying to sanitize the page, the browser blocks rendering completely if an XSS attack is detected. This is very useful for older browsers. Another header is referral policy. This helps prevent leakage of sensitive URLs like containing tokens, query param, or private data. Strict origin when cross-origin means send origin only for cross-origin requests. Instead of setting environment variables in your env file, you can also set them here. For example, I create two variables, course enabled and custom key. Course enabled allows you to toggle course protection dynamically. If it is not defined, defaults to true. Custom key allows you to set other secrets like API keys and encryption keys. Protect APIs with CSRF. What is CSRF? CSRF means cross-site request forgery. How it works? First, imagine you logged in to your website like 10-minute portfolio.app. Then you made a request like upgrading your account to premium. So you add your payment code and details, everything. Then boom, an attacker tricks you into making that request to your server without your knowledge. And then he can perform unauthorized actions like changing the amount from $4 to $1,000, for example. CSRF protection is critical in crypto platforms, in banks, and any financial applications. So how CSRF protection works? CSRF generates fresh for every sensitive request or form. So when you make requests for the payment form, the server sends you a CSRF token. Then you submit your form with this token. Afterwards, server validates token, then allows request. Otherwise, if the token is invalidated, the server throws CSRF error. How it works practically in Next.js application. For backend framework like Express.js or Next.js, they provide built-in features to handle that, but with Next.js, you need to implement that from scratch. Let's get back to our code editor and create a folder in lib folder called CSRF and then add a file called index.ts. Inside this, we'll create a new function called validate CSRF token. This is an async function that takes a Next.js API request. and returns a boolean indicating whether the CSRF token is valid, true, or not, false. For every task, we will use try-catch statement. First, clients can store token on headers or cookies depending on the data, so we'll check both. Firstly, I retrieve the CSRF token stored in the user's cookies. Let's create that function. It takes nothing as arguments and should return a promise type string or null. We get access to the cookies store. Then read the CSRF cookie value by name. And return the token string if found. Otherwise, return null. About the name, we are going to set names for a CSRF, but you can create whatever you want as long as frontend and backend match. So for token, it will be CSRF token. For cookie name, it will be double underscore CSRF token. For header name, it will be X CSRF token. The token length is 32 characters, random string. Max age, token is valid for 1 hour. After that, the user must get a new one. Same site, lax, means cookies won't be sent with most cross-site requests, like posts from another site, but will be sent with top-level navigation, like get. Secure, true, means cookie only sent over HTTPS. HTTP only. First, so frontend can read and send token in headers. We're also going to get token from headers with function get CSRF token from headers. This function reads the token from the HTTP headers. If the header is not present, it returns null. Now, if no CSRF token was found in the header and the request is a post, since CSRF attacks usually target state-changing operations like post, put, delete, or patch, clone the request because our Next.js body, form data, JSON, and so on can only be consumed once. By cloning, you can safely read the body for CSRF token extraction without breaking the original request stream. Then extract CSRF token from form data in get CSRF token from form function that we need to create right away. It takes the request and return a promise of type string or null. Inside, we get the form data from the request and then extract the token from it using get method. At this point, if no token is found on both headers and form data, return false. Also, in case token stored in cookie and header is found, but both do not match each other, return false as well. Otherwise, we can go ahead and check the expiration with validate timestamped token. This function checks whether the token is still valid. fails, return a CSRF error and reject the request. At the end, we return false. Now, we can implement the main entry function with CSRF Protection. It takes a request and a handler. First, we skip CSRF forget head option request. Why? Because CSRF protection is only needed for state changing requests like post, put, and delete. Get, head, and options should be safe. So we don't need CSRF validation here. Then, we also should skip CSRF for webhooks endpoints. Why? Because we used to validate webhooks using signatures or shared secrets. Then we can call validate CSRF token function to validate the token. If token validation fails, log the attempt. Return 403 for building with an error message. If everything checks out, CSRF is valid. Proceed then to run the actual API route. Let's apply this middleware to our Next.js middleware. After course protection, add your CSRF protection there. So we also need to create an API GET request to generate the CSRF token. In API folder, create another folder called CSRF. Then inside, add a route.ts file and create a Next.js request. Here we are going to generate a token using generate and set CSRF token. This function returns the token and our Next.js response. back to our API, we can now send the token generated to the client. After that, by default, CSRF will generate every new token for each request except this route itself and the API main route. So from the middleware file, let's implement that one. Building APIs routes. Finally, it's time to create our first API routes. First, we will start with admin APIs. So in Next.js app router, API routes live under app/API folder. You can structure this folder as you want, but I personally create a folder for admin, and inside this folder, I create all admin APIs. So here we'll create APIs for template collection first. Then create a folder called templates with X at the end, remember? So inside this folder, we'll create CRUD APIs like get, post, put, and delete. Each one has its own role. For example, get is used to get all data from a collection. Put is used to update a single collection. Post is used to create a single collection. And delete is used to delete a single collection. There is also a last one that most developers forget, and this is the batch HTTP method. This one allows you to update a single collection like put, but just partially. So in Next.js, we can perform API routes for all of that. Let's create API routes for get and post first. For that, inside the templates folder, create a route.ts file. This file used to handle the get and post HTTP methods. In other words, we are going to create API handler for get and post HTTP method. The first one is get handler. This is an async get handler for Next.js app router API routes. It takes the frontend request containing HTTP requests, including headers, query params. For all API routes, I will wrap all logic in try-catch statement to handle errors gracefully. Inside this statement, I declare the auth code, then connect to MongoDB. After that, I get query parameters using request.nextURL.search params. It gives you all query parameters from the URL. After that, I pass filters from query on the frontend. We'll be able to list templates with data table, so we need to handle filters like page, limit, status, search. Also, we'll be able to filter by premium templates and tags. Once we have prepared and built a filter object to pass to the repository query, we call a repository method that queries MongoDB using the filters and return a list of templates that match the criteria. If everything goes well, we respond with JSON containing the templates and our success through flag. Otherwise, we send an error response with 500 status code. The next API route we are going to build is for post HTTP method. This one allows you to create a single template. It takes the incoming request and then we always call first the auth gods afterwards, we connect to MongoDB then extract JSON body from the request and next we are going to validate input with Zod. Here I define a schema that describes the shape, type, and roles for your data. Then I save pause some data against that schema. What does save pause do? Save pause checks whether body matches the rules in template schema. It does not throw an error, unlike pause. Instead, it returns an object with two possible outcomes. We will see that later, but for now, let's create our schema. Validate schema for collections is stored in validations folder inside the lib folder. Here, we can create a new file called template.ts, and we can also create our Zod schema. Zod is a TypeScript first schema validation library. You can use Zod on both frontend and backend. So here, I'm going to show you how to create a high-level Zod schema from scratch. First, we need to install Zode using burn. Once installed, import Zode and then let's see how we can use it. Depending on what we are going to validate, here our body data is an object containing template inputs. So we are going to define an object where inputs, data, or the object's properties and values or their validation rules. Each property will be validated and typed. The first property is title, which is a string. And instead of using string everywhere, we are going to create a Zode helper called saveString. So create a file called zodehelper.ts. Inside, create a function saveString that takes the field name, the minimum length, and the maximum length. Then it should return the same field name. Then I add the trim function to trim the string and minimum function to set the minimum length. And maximum function to set the maximum length. After that, export and import saveString and add it to this title property. After validation succeeds, transform function modifies the value before returning it. Up the input. Create then this helper function. It takes the input and return the input but cleaned. Inside, it's going to do a lot of things. Such as removing anything that looks like an HTML tag, removing leftover, removing non-printable control characters, removing quotes and parentheses, removing leading and trailing spaces, tabs, new lines, keeping only the first 1,000 characters. Now, in the template schema, the next property is description. This is required with 1,000 maximum length. Tags must be an array of strings, each tag validated with safe string between 150 characters. Trimmed, then passed through, sanitized as all string. Finally, at least one tag required. Maximum 10 tags allowed. Thumbnail must be a string. Trimmed and must be a valid URL. It must end with an image extension. And also sanitize it. Font must be a string between 1 and 100 characters. Sanitize it for safety. Primary color and secondary color must match HESC color schema. This property must be a string, must also match this regular expression and then sanitize it. Premium must be strictly true or false. Status only accepts one of two exact values, active or inactive. We just finished the template schema now. I also want to validate the ID of template. Create ID schema. This starts as a string schema. Then I check if the string is a valid MongoDB object ID, 24 hex characters. If invalid, throws invalid template ID. Now, I also want to create update schema for eventually update the template later with template update schema. This schema takes your template schema, then makes all fields optional with partial function. This is perfect for update requests where you might only want to send a subset of fields. We are done with template schema. Now it's important to add TypeScript for those schema for type safety. So I create template create input that extracts the TypeScript type from our template schema. And I do the same for template update input. Great, back to our API route. Unlike pause that just throws an error, safe pause returns an object with two possible outcomes, success case and failure case. In case validation failed, return an error response with HTTP status 400 BAT request with validation error. And also send the errors detail containing an object of key value pairs. Each key is a field with value and array of error messages. Something like that. So that you can render that later on the frontend app easily. Now, if everything is fine, we can get the data sanitized and validated that we then can assign to data constant typed as template create input. After that, we save this data to database with create function from template repository. If template is saved, return success response with status 201. If something went wrong, During this operation, return error response instead. This is API route for get and post HTTP method. Let's create API route for the rest. Next.js allows you to create API routes using dynamic segments. So, symbol ID in square brackets define dynamic route segment. The name inside which is here ID becomes the parameter key you can read. So here, create this ID param with square brackets as a folder, and inside this folder, create a route.ts file. What we are doing here, we are going to create the first handler to retrieve a single template. So the first thing to do is create an asynchronous function that takes the request but also the params containing the ID param. After calling off God, we retrieve this ID from params. And fetch data using the function we created in template repository find by ID. If template is not null, we send the result with a success response to Frontend app. Otherwise, we throw an error. Next, handler allows you to update or template. It takes some arguments as getHandler, then call the auth guards Afterwards, get the template ID from the URL. Post request body. Validate body with Zode and template update schema. Handle validation errors. Extract validated data. Once data is sanitized, validated, and typed, we can update in repository If template is null, return 404 not found. Otherwise, return the updated template and a success message. If something unexpected happens, like DB down and handled error, return 500 internal server error. The delete handler allows you to delete a single template. So first, we define the delete asynchronous function that takes some same arguments as put handler inside. We do same thing. We call auth guards get ID from params then validate ID with zone and ID schema. Once data is sanitized and validated, we can delete the template with delete function that we created in template repository. This function, once executed, should return the deleted template. If not, we throw a not found error. Otherwise, we return a successful response. Now we are going to create API route for user. First, create a folder user in API folder. Then create dynamic segment ID and create inside this folder or API and API route.ts. Now we are going to create here a get handler to allow users to retrieve their information. So this is an asynchronous function that takes the incoming request and the route parameters containing the user ID. Then we run our custom authorization check. In this case, require admin is false, so it just checks that the user is authenticated and does not require the admin role. Then we ensure a MongoDB connection before a query. Next, we get the ID from the route. Then we use our repository portal to fetch the user from the database by clock ID. This returns either the user object or null if no match found. In case it's null, we return a not found error. Otherwise, we return the user data. Also, we always catch any unexpected error. The last route handler is put. Here we allow the user to update its data. This runs when a client sends an HTTP put request to this route. It takes the request object and the route parameters. First, we run authorization checks. Connect to database. Get ID from the URL. Read the JSON request body containing new user data. Use Zold user schema to validate the body. In lib/validation folder, Create the user schema file called user.ts. Here we define a schema for an object with specific fields like email and name. Email must be a string, must be a valid email format. After validation, it should be sanitized. Name passes the helper function save string we wrote and then passes the transform function. Then we set strict function to this object. This ensures no extra fields are allowed in the object. If the input has additional properties, Zog will throw an error. Back to API route handler. If validation fails, then return 400 back requests with detailed field errors. Then we ensure TypeScript knows data is valid and matches the schema. After that, we can look up the user by clock ID and update it with data. This will return the updated user object if found, null if no user was found. If no user exists with that ID, return 404 not found response. If the update worked, then return the updated user and 200 status code. Finally, catch any unexpected error. Next API route is for portfolios. Create folder portfolio, then create a file route.ts inside. In this file, we will allow the user to retrieve its portfolios and also create a new portfolio. First, let's create the get handler to get users' portfolios. Create an async function get that takes the incoming request and the route parameters like user ID. Then run the off guards. Get query params called search params from the request.url. Also, we get ID param. This one is set in the URL path and it's different from the query params. Very important to know. Then we pause filters like page limit defaults to 1 for page and 10 for limit if not provided. We also set optional filters such as status, search, template ID. Then we build a MongoDB style query object for the database. Afterwards, we fetch the user from the database using their clock ID. If no user exists, return 404 not found with an error message. Next, we call our repository function to fetch portfolios belonging to this user. If everything worked, return a 200 status code. If any went wrong, catch any error in the process. Next, let's create the post handler. This is an async function that takes same arguments as getHandler. We call the auth called without role admin. Then connect to MongoDB. Read the post request payload, get the portfolio ID param, then throw an error if the user does not exist to prevent creating a portfolio for a non-existent user. After that, we create a URL-friendly identifier for the portfolio. Then we combine body data with slug and user ID to prepare the full payload for validation. We validate that object with create portfolio schema. Go to lab/validations folder and create the portfolio schema file inside this folder. Let's define our portfolio schema. The object contains user ID, must be a non-empty string to ensure a portfolio is always associated with a user. Name is safe string with minimum 2 and maximum 100 characters. After validation, it passes the sanitization filter. Template ID is required string for the portfolio template. Slug is a URL-friendly identifier for the portfolio. It must match regex, lowercase letters, numbers, and hyphens. Profile field is validated using a nested schema portfolio profile schema. It contains the main portfolio informations, such as name, that must be a string between 1 and 100 characters. After validation, it should pass the sanitization helper. Title must be between 1 and 200 characters. Sanitized after validation. Bio, short biography of the user, must be between 1 and 500 characters and sanitized. Location is optional. If provided, must be between 1 and 100 characters and sanitized. If not provided, keeps undefined. Email. Required email field. Validates proper email format. Phone. Optional phone number. Trims. White space if provided. Website. Optional website URL. Must be a valid URL if provided. Maximum 100 characters. Can be empty string. Sanitized if not empty. Profile photo is optional profile and must be a valid URL. Cannot be empty string if provided. Trims white space. Social media. An array of social media links validated with social media schema. Maximum of 5 links. The social media schema is a nested schema that contains platform, that is the name of the social media platform, example LinkedIn, Twitter, and so on. Must be a string between 1 and 100 characters. Sanitized after validation. URL is the link to the social media profile. Must be a valid URL. Use trim function to remove leading, trailing, white space. Skills is an array. Each item in the array is validated against its respective schema, skills schema. Skill schema contains name or string required with 100 maximum length and sanitized. Category uses skill category enum. It contains a list of values, frontend, backend, and so on that a category should match. Proficiency, same as category but with different values like beginner, intermediate, advanced, expert. Certifications is an array. Each item should match the certification schema. This schema contains name, required string with maximum length 100, and sanitized provider, same as name field. Issue date is an optional date. Expiry date is also an optional date. Credential ID is an optional string. Credential URL is also an optional URL. Experiences is an array of nested schema, experience schema. This schema contains required string fields like title, company, and location. Then a start date, a date that must be a valid date, not nullable. End date, this is also a date. It can be null and must be a valid date. Greater than start date. Is current is a boolean with default value false. Description is also a required string. Is a required string sanitized. Achievements is an array of string. When provided, string is required and maximum length is 100. Technologies is an array of strings, same as achievements. Projects field is an array of objects. Every object should match the project schema. This project schema contains many strings like title, description, thumbnail, Also, technologies fields, which is an array of strings demo URL is a string trimmed and must be a valid URL. GitHub URL must also be a string trimmed and must be a valid URL. Is featured is a boolean with default value false. Completed date must be of date and it is optional. Now we have settings, which is an object with default values. This field should match the portfolio settings schema. This schema contains boolean field like is public, allow comments, and show contact form. With default value. Also, string fields like custom domain, SEO title, SEO description. There must be string not required as minimum length is 0, and if provided, they must be sanitized. Another field is status must match the portfolio status enum. This schema portfolio status enum is a list of value drafts, published, and archived. Last field is view count, must be a number, specifically an integer, and must be a positive value. Besides, it can have 0 as default value. At the end of create portfolio schema, we add strict function to avoid unexpected field. Now, once we created this schema, we also need to create the update schema. So here we define update portfolio schema. It takes to create portfolio schema and make all fields optional with partial function. Then we extend it by adding the ID field to it. You can also add status if you want. After that, I'm going to add a schema for the slug field for later use. The slug must be a safe string with minimum 3 characters and maximum 50 characters. I also set a regular expression to avoid unexpected characters. To finish the portfolio schema, we need to extract types from our schema, both create and update portfolio schema for type safety using z.infer. Here we take the incoming body JSON request data and merge it with slug generated earlier, user ID from the authenticated user in the database, run it against create portfolio schema using save pause function. If schema validation fails, return a 400 BAT request response with errors messages. Otherwise, pull out the typed and sanitized data from zone validation. Pass validated data to our repository layer and create the portfolio with function create portfolio. This action should create and return the portfolio. If not, throw an error. Otherwise, return the portfolio created to the frontend app. Here we have a TypeScript error. Let's fix it. Then next API route we will create is for dynamic segment. This will allow user to perform action in a single portfolio. So create the ID segment inside portfolios folder and create an API route here. Also, create more folder like publish and duplicate. Back to our dynamic segment API route file. Here, I declare a get handler for fetching one portfolio. I ensure the user is authenticated. Then I extract the ID of the portfolio from the route params. If no user ID return, 404 not found. I call auth function to get the current logged in user's ID. Then I get portfolio with function get portfolio by ID. If not found, return 404 not found response. If found, return the portfolio with 200 status code. Next, we declare or put handler for updating a portfolio. Again, check authentication. Extract the portfolio ID from the URL. Ensure DB connection is working. Pause JSON request body. Confirm logged in user. If no logged in user, then return 404 not found. Validate request body against your create portfolio schema. If validation fails, return 400 bad requests with error details. Create a strongly typed update payload including ID. Call the repository method to update the portfolio in DB scooped to user. If no portfolio was updated, then return 404 not found. On success, return updated portfolio with 200 status code. Now we are going to create API route for patch handler. A patch handler will allow the user to update a portfolio partially. In this case, it's about the status. First, let's define the patch HTTP method handler for your published API route in Next.js. It takes the incoming request and the route parameters. Then we run a middleware check before doing anything. We call auth function to fetch the current connected user. If no user is found, return 400 batch requests with user not found. Then post request body. Validate that status exists. It's one of the allowed value. It can be published, draft, or archived. If invalid, return 400 batch request. Check user subscription plan by fetching the user record so that I can count how many published portfolios the user already has. By default, there is a business rule. Free users can only have one published portfolio. So if they already have one, return 200 status code. With message upgrade your plan to publish unlimited portfolio. Otherwise, if this is the first time he is publishing his portfolio, or if he has premium plan, update the portfolio status to publish and return the portfolio to Frontend app. The user can also duplicate a single portfolio. So this is handled by the API route in duplicate folder. Inside, we define a patch handler for an API route in Next.js that takes request and the route parameters. Then run a guard to ensure the user is connected. After that, connect to MongoDB. Get the ID from URL. Get current user. If no user found, returns 400 back request with user not found. Calls the repository function to clone the existing portfolio. If duplication fails, return 400 batch requests with an error message. Otherwise, if everything works, return a 200 status code with the newly duplicated portfolio. We also need to create another API route to handle portfolio preview. For that, create a folder inside portfolios folder called preview. Inside this, another one called dynamic segment slug, and create the API route file. Now here we define the get handler used to request that data. It takes the incoming request and the route parameters. As always, we run our goal to check authentication, then connect to MongoDB. Also, extract slug from URL. Find portfolio. If no portfolio exists, for that slug, return 404 not found. Otherwise, return a success response. Now we also need to integrate AI to allow user to fill out forms when building its portfolio. So create a prompt folder inside user folder and we'll have many API routes such as profile, experience, and projects. Let's start with profile prompts. First, let's create the DeepSeek client. Initialize OpenAI compatible client configured for DeepSeek. Use an API key from environment variables. Install necessary dependencies such as AI SDK / OpenAI. Also, then get the DeepSeek AI keys. For that, go to DeepSeek website, create or login to your account. Then from API keys section, here create a new token. Copy it and add it to your environment file. Now we can continue and set base URL. After that, let's create the post handler. This is an asynchronous function that takes the request inside. We read request body. We extract optional industry and role values to make the generated profile context aware. After that, we build the prompt. This should return AI-generated text. Expected to be raw JSON. We convert then the AI's text into a JavaScript object. If something goes wrong, it will throw an error if AI generates invalid JSON. Otherwise, return a structured JSON response with the generated profile. We'll do the same for experience prompt and project prompt. The only thing that is different is the prompt, so you can get the source code, copy and paste the prompt, and here you go. Now, let's build the last API, which is public APIs. Public APIs are used to fetch data that are not protected by auth. Anyone can access it. So inside public directory, we'll need to fetch portfolios, templates, and also allow anyone to send a message through the contact form. Therefore, create these folders. Let's start with portfolio API route. Here, we create the async function get handler that takes the incoming request. We connect to database, extract query parameters like page, limit, and plan. Build a filter object for searching portfolios. Call repository get public portfolios to fetch data. Return JSON with paginated results. Create a dynamic params slug in portfolio folder. Then we need to create this route handler. It takes the incoming request and the route parameters. Then we get slug from route params like slash portfolio slash slug. Then we fetch only published plus public portfolios. Populate template ID to fetch template details. If not found, return 404. Otherwise, increment view counter for tracking popularity. Return portfolio JSON. Also, we need to create API route to validate user portfolio Clerk validity. So create an API route in validity Clerk folder. Then create the route handler it takes to request and afterwards we read Clerk from query string. Optionally exclude a portfolio ID. We call validate slug availability function in repository. Return whether the slug is available or already taken. And the last API route we are going to build is templates API route. This allows to access templates publicly. So what are we going to do is to create the route.ts in templates folder, create the route handler that takes the request and then connects to the database. Read query parameters like page, limit, status, search, tags, and premium. Build a dynamic filters object based on the query. Fetch templates from the repository using these filters. Return templates in JSON format. handle errors gracefully with login, we just finished API route. Great job. Now let's move on to set up Clerk Webhook. A webhook is basically an HTTP callback sent by an external service like Clerk. Every time a user creates an account on your website, this request is sent to a specific URL that you need to provide. This URL is different for each cloud services. For Netlify, the default URL is go to Clerk Dashboard, Configure section. Scroll down, Webhooks section. Then add an endpoint. There, add your API domain plus .netlify/functions/clerk webhook. After that, add a description. It's optional. Then select events. In our case, select user created, deleted, and updated events. Once created, Clerk will create a webhook token for you. This is useful to validate your webhook later. So add this inside your environment variables file. Here, I create a new variable called Clerk Webhook Secret with this value. Then, create a folder Netlify at the root of your project. Then inside, add another folder functions and then create your webhook, Clerk Webhook.ts. Then open it and define a Netlify function, which is the entry point. It takes the event that contains request details like HTTP method, headers, body, and so on. Then allow only post request. Webhooks must be sent as post. Any other method like get returns 405 method not allowed. Then extract request data. Headers contains metadata sent with the request, which is important for verification. Payload is the raw webhook body, which is a JSON string. If nobody, return not found 400. Extract sfix signature headers. If any are missing, reject with 400. Verify webhook authenticity. We use the secret key webhook secret to verify the payload was not tampered with. If verification fails, reject. Then connect to database. Handle event types. Route different event types to different handlers. User.created when no user in Clerk. Create in database. User.updated when Clerk user updated. User.deleted when Clerk user removed. Any unknown events get logged but not processed. Return response a 200 tells Clerk we got it. Don't retry. If an error occurs, return the error. Now we can create function for each event. For handle user created, this runs when Clerk sends a user.created event. First, we extract user info. Then get primary email finds which email is marked as the primary one in Clerk. If user exists in DB, if suspended, reactivate them. If already active, log and do nothing. Check by email sometimes, or user deletes and recreates Clerk account with the same email. If found by email, relink new Clerk ID to old DB user instead of duplicating. Create new user if none exists, and a brand new record in DB with default plan and role. Sync clock private metadata makes sure clock's record has the same role and plan. Update clock only if metadata does not match. For handle user updated function, this runs when clock sends or user.updated events. Here we extract user info. We get primary email. We find user in database. And we update DB record. Then we also update email name and updated at field to match clock. For handle user deleted, this runs when clock sends or user.deleted event. Here we extract clock ID find user in database. If not found, log warning do nothing. Soft delete the user data instead of hard deleting the record. Mark status as suspended. Once your webhook is done, deploy to Netlify. add the rest of environment variables online, and redeploy the project. Testing with Postman. I'm going to show you here how to test your RESTful API like a pro. First, install Postman extension. Then login. After that, create a workspace for this project. Fill out the form and click on Create. Then you can add more info information later. Let's skip this. Here, select your workspace you just created. Then here, select environment. An environment in Postman is a set of key value pairs that you can reuse across multiple requests and collections. This allows you to switch between setups, for example, development, staging, and production. Once you've finished, select development, then create variables for that one. Variables for an environment or placeholders that store values you can reuse across your requests, collections, or environments. So we'll need to create many variables like base URL. This is the common root address of your API or backend server that you use as the starting point for all your API requests. Name base URL. The base URL type is default. Then the initial value. This is the value itself. Just add your local server API. Now we also need to add another variable called token. This is a piece of data that is used to prove your identity and permissions when making API requests. For testing, Clerk provides a GWT template that we can use to create a test token. So go to Clerk dashboard, configure section, scroll down to GWT templates, then add new template. Here, add the token name, add the token lifetime, scroll down on customize section token and set the metadata key. With value public metadata, this allows you to set metadata like role into your token and save. Now, it's not over yet. Go to Clerk Docs and search for console log token. Click testing with Postman. Copy this command. How to use it? This command allows you to get a long life token, but it is needed to be connected. So you are going to implement login feature so that you can get connected and retrieve that token. Let's implement off with Clerk. First, create a group root in app folder, then add folders for login and sign up inside this folder. once login page is set, we need to wrap Clerk Provider to the app. So I use to add all external libraries inside our root provider called index.ts. So here define and export default function providers that takes as argument children and then renders that children. So we can now create our Clerk provider and add it to this root provider. Now in main page.tss, add a Next.js link component to navigate to login page. From here, we can also sign up, so let's create the sign up page. Copy login page component and copy to sign up page, then edit the content. Great, now we can create new account and login. After successfully connected, open DevTools, go to Console panel and add Allow pasting to disable security issues. Then paste the token command. Go back to Postman extension, go to environment dev and add variable token with type secret and add in initial value section the token generated. Then we can start creating collections. In Postman, a collection is a group of saved API requests that are organized together for easier testing, sharing, and reusability. So create folders like admin, public, user, and CSRF. I'm going to show you how to make a CRUD operation request for templates API. Then you should complete the rest of APIs. First, select admin, then select your environment, which is development. Then, from authorization section, you should add the auth token because admin requires auth token to allow users to get access. When you set up one, it's automatically set up for the rest. Now add request read inside admin collection. Here, for base URL, we are going to add /API at the end. Now, by default, you need to set the user connected as admin so that you can test the admin templates. API, go to Clerk dashboard and add role admin to the connected user. You can also add plan user if you want. Now back to API read admin template, set the API endpoint with the base URL variable, and you can see we receive the data with response 200. Now let's test as well the rest of APIs. The next is post request. Here we need to send a content type application JSON format. So in Postman, select raw and add the JSON in this field. Here we are going to fill the template data. Once you add all data, you can hit send. We get an error, unexpected token next to thumbnail. Let's check this out. Now we have zone validation errors. This is a proof that our zone validation is working perfectly. Let's edit these values. We got another error. This is a try-catch statement error, probably from Mongoose validation. Let me see. This is about the thumbnail field. It's saying that the URL provided is not valid. So we are going to edit the zone validation and give it the right URL then. Now, we set the right zone validation for this field. Let's set the right value. And that's it. The template has been created. Let me get that one record only with read one request. Great. The next one is update request. So copy post request data JSON and add it here. Then we can just edit and hit send. All right, the last one is delete request. It throws an error. Let me see, it's saying invalid response status code 204. I think we should change 204 to 200. Let's try again. Great job. Backend done. Now get ready for part 2. The frontend in Next.js. We are talking API magic with Axios and built-in virtual logic, multi-language support with React Intro, SEO and rendering with Next.js, server-side rendering, static side generation, and incremental static regeneration. Rock-solid forms with Zode and React Hook form, stunning reusable components with ShadCN UI, smooth animations with framer motion, gorgeous responsive design with Tailwind CSS. Part 2 is where your app comes alive. Don't miss it.